Good evening, Angel. Let's have a look at this question. So, first thing I always do is write down the numbers we've got. Now, we've got the masses for the white ball and the mass for the red ball. I've given them as grams and kilograms over here. We know that the total momentum before is equal to the total momentum afterwards. So the total momentum before we can calculate as the mass in kilograms multiplied by the velocity plus 0, because the velocity of the red one is 0, this bit just is 0. Is 1.1297, or we could use it in grams. We could do 143 times 7.9 is 1129.7. So total momentum before equals total momentum afterwards. Momentum before is just the momentums of the white ball and the red ball. The white ball's momentum is that, the red ball's momentum is that. Add them together and we get that. This one in kilogram meters per second, this one in gram meters per second, so we've left it in grams on this one. Total momentum after is the same as before. So if we take the one that's done in kilograms, we can say that 1.1297, that's the momentum before, is equal to the momentum afterwards. The momentum afterwards, the white ball stopped, so that's just a 0. We don't need to add that one in. So we just need to worry about the velocity of the red ball afterwards multiplied by its mass. If we're doing it in kilograms, that's 0.150. Rearrange for V. 1.1297 divided by 0.150, it's about 7.5 meters per second. But if we were to do the same thing with the mass in grams instead of kilograms, it would be our value from up here, 1129.7, and our value in grams for the mass of the red ball, 150. Rearrange for V, again 7.5-ish meters per second. So why do we get the same answers when we converted into kilograms and when we haven't bothered, we just kept it in grams? Let's have a look at this. The velocity afterwards is going to be equal to mw times vw. Mw is the mass of the white ball and the velocity of the white ball beforehand. That's the initial momentum. But maybe a thing to put up here before would be that the mass of the red ball multiplied by the velocity of the red ball afterwards is equal to the mass of the white ball multiplied by the velocity of the white ball. We could put that up there. Rearrange that for the velocity of the red ball afterwards, gives us that. Now, if we use grams, we've got the mass of the white ball, we've got the mass of the red ball, we've got one on the top, one on the bottom. Both are measured in grams, so they cancel out. They cancel, we don't need to worry about them. If we do it in kilograms, they still cancel. We end up with them cancelling out, and we end up with an answer just in meters per second, either way round. So you don't have to worry about the conversion in this case, simply because when you do this part of the calculation, when you've got the mass of the white ball on the top and the mass of the red ball on the bottom, as long as they have the same units, they're going to cancel out, and you're going to be left with just meters per second, which is what your answer to be in. So grams cancel with grams, kilograms cancel with kilograms. That's that.